me, myself, Elijah Grammas, and Bobby Turner. Carbon emissions from electricity sources. So, from our chapter, 27% of the 51 billion tons of carbon emitted into the atmosphere um, are from electricity sources, so how we plug in. We chose to do the topic of nuclear power, which is 10% of all carbon emissions. And we chose particularly nuclear fission and nuclear fusion. So the history of emissions within nuclear power and electricity. In 1789, a German chemist, Martin Klaproth, discovered uranium, which is used in nuclear power. But it took another 150 years until they kind of found something to do with this, and a guy named Enrico Fermi experimented time after time to get what is called now nuclear fission. And then in 1942, at the University of Chicago, the first nuclear reactor was tested, which was a huge breakthrough, because this was kind of, when people started to realize there's a lot that you can do with this. But at the beginning of nuclear inventions, weaponry was one of the first things that people kind of dove into, and as a lot of people know in history, on the 6th of August in 1945, America dropped an atomic bomb over Hiroshima, which killed 80,000 people, and after that, because of radiation, killed many, many more thousands. But in 1946, the Atomic Energy Commission was created, which was kind of a goal to make nuclear things more peaceful, and there's no need to make these bombs that are crushing people to kill people. So they kind of tried to make it so people would use it for energy, and there was a lot that you could take out of it. And there's some more historic events with nuclear power, and some of these you may have heard of, some maybe not, but in 1979, at 3 Mile Island, which is in Harrisburg, Pennsylvania, radiation leaked from water that spilled out of the cooling system, and the accident was caused by a combination of mechanical failure and, of course, human failure, or human error. It triggered fear and confusion, but luckily nobody was hurt in this accident. But roughly a decade later, in Ukraine, Chernobyl, one of the 4 nuclear reactors exploded and forced tens of thousands from their homes, and many were killed at the time. And that place is still radiant to this day, and perhaps on Earth Day, if you choose to watch this movie by David Attenborough, you will see pictures of what happened in Chernobyl.
What's to come for the future of nuclear power? There is another completely different form of nuclear power that would work significantly better than nuclear fission in the future. It is called nuclear fusion. Nuclear fission is the current form of nuclear energy that receives its energy by splitting atoms apart. Nuclear fusion is quite a different process. It pushes the atoms together, which triggers the process of fusion. The sun processes its own energy the same way that nuclear fusion does. Hydrogen in the sun is extremely hot. The sun is about 50 million degrees Celsius. Hydrogen in that environment forces it to go into a state known as plasma. When particles are heated up to that extent, they start moving faster than the little kids on a sugar rush. The atoms then begin to start to hit each other and basically fuse together. This causes hydrogen particles to turn into helium. This process releases a ridiculous amount of energy. After that, it can be harnessed and turned into electricity. Hydrogen used for nuclear fusion will most likely be extracted from the seawater. All in all, nuclear fusion would create fuel that's cheap and reliable. A benefit of nuclear fusion is that waste products will only be radioactive for hundreds of years, versus hundreds of thousands of years from waste plutonium and other elements from nuclear fission. After analyzing and learning about nuclear fusion, there is one major obstacle that must be taken into account. So much energy is going to have to be used to make hydrogen reach a high enough temperature to turn it into plasma in the first place that oftentimes you're putting in more than what you'd get out in return. Despite this one drawback, nuclear fusion could change the life on planet Earth for the better. I believe strongly that as society continues to advance the concept of nuclear fusion, it is not too far-fetched to put it into practice. Definitions for the chapter. Plasma, a state at which hydrogen particles become very hot. Nuclear fusion, when atoms fuse together or smash together to create energy. Nuclear fission, the current form of nuclear power used across the globe, when atoms split apart to form energy.
Green premium for nuclear power. Let's get started with the definition of green premium. Green premium is the additional cost of getting all of the power from non-emitting sources, including wind, solar, nuclear power, coal, and natural gases, fired plants equipped with devices to capture the carbon they produce. So the green premium cost for zero carbon energy sources will force households to pay 15% more than what they pay for now a month for the average home. Bill Gates, the author of How to Avoid a Climate Disaster, stated, one study suggested that decarbonizing Europe's power grid by 90 to 95% caused rates to go up roughly 14 euros per month for a typical household in the European Union. In the United States, it would cost an average $18 a month for each home. After analyzing the green premium of a zero carbon electricity plant, the cost isn't as bad as it appears to the eye. Americans would have to sacrifice 4 cups of coffee each month to be able to pay the extra electricity bill for the month, which isn't asking a lot considering switching to a zero carbon energy source would benefit both humans and the environment. Nuclear power doesn't cost a lot to produce energy, but the facilities and the plants are what drive the green premium up. Families in America tend to be paying 10 cents per kilowatt hour, which compared to fossil fuel energy is very similar. Fossil fuel powered generation usually costs between 5 cents kilowatt per hour and 18 cents kilowatt per hour, which, as you can see, these numbers, nuclear power is right in the ballpark.
The end goal for society. Did you know 860 million people don't have access to electricity? Therefore, parts of Africa are not going to be able to attempt to eliminate their carbon emissions, considering they have much bigger tasks at hand that must be completed first. Climate change is an issue that must be fought at a global scale, but it's hard to get all countries on board considering some don't have electricity to start with. Creating zero-carbon electricity sources require a certain level of modernization, which some countries just aren't there yet. It is hard to defeat a large-scale climate issue if you can't even turn on your light. Therefore, in order to reach our goals, energy must be given to all first, which will then allow developing countries are on their 2 feet, then they can start modernizing and advancing their energy sources so that they emit zero carbon emissions. Therefore, in order to reach our goals, energy must be given to all first, which will then allow